So day 2 is graphing logs. Thank you, Alex. All right, so logarithms and exponentials, they are basically inverses, okay? These are inverses of each other, which means that basically they're opposites in every single way, all right? So let's take a look at both of our graphs, all right? So I have y equals 10 to the x power, all right? So let's take a look at this. Properties of a parent exponential graph. Well, I know this is an exponential because there's an x in the exponent, right? So what I'm going to do is, okay, exponential. I'm going to put a star on my domain. Why? What is the domain always? Yeah, negative infinity to infinity. Asymptote. What kind of an asymptote do exponential functions have? Well, okay, it is 0, but what kind does it have? Horizontal or vertical? Horizontal. Horizontal asymptote. Then is that a Bux or a Hoy? Hoy. So is y equals 0 because your k is your asymptote, right? This is what we just did. This is what you just did on the mini quiz, right? All right. So now all this, the range, increasing, decreasing. Well, you know what? Let's graph it. So let's go to our calculators and let's put in y equals 10 to the x. N to the x. Okay. All right, so go to second graph. And let's go and get some nice points. So what do we have? When x equals 0, what is your y? When x equals negative 1, what is your y? When x equals 1, what is your y? Should we do 2? It's 100, right? So no, let's not do 2. How about negative 2? No. 0.01, so that one doesn't, right? Okay, so let's go and graph our asymptote. We said y equals 0. So hard to see here. Okay, there we go. Right? Y equals 0. I have a horizontal asymptote. Now let's graph this. 0, 1. 110. Negative 1.01. I mean, that's really close. And then negative 2.01. I mean, that's basically on 0, but it's not. All right, so then when I go and connect this, well, there we go. There's my exponential. Right? So tell me something. What is the range?
0 infinity.
Good. Is that crooked? That's a little crooked. No, it's not. Yeah, starts at 0, and then your graph goes all the way up to infinity. So thank you, Mitchell. Range is 0 to infinity. Now, does it have an increasing or a decreasing interval? Let's take a look.
It's increasing.
Good, because when you look at this graph, it is going up from the left to the right. Yes? So it is increasing, same as the domain, right? Increasing from negative infinity to infinity. Is it decreasing anywhere? No. So we will put none. Now let's see, y-intercept. What is the y-intercept here? When x equals 0, my y equals what?
Y equals
Good. 1.
0,
All right.
1.
So 0, 1. Good. Now, do we have any zeros or x-intercepts? Does it cross through or touch the x-axis? Right there, that red line? No, it can't, because that's where the asymptote is. And remember, your graphs are not going to touch that asymptote. So zeros, none, because the asymptote is there. Now the last part here says, as x approaches negative infinity, well, that's talking about your left arm. The left arm of this graph is going where? Is it going up? No. Is it going down? No. It's getting stuck. And stuck at what?
0.
0. Your asymptote. So as x approaches infinity, that's your right arm. Look at your right arm. Where's that going? Straight up to infinity. Good.
And beyond.
All right, so, you guys are doing really great with this exponential graph, right? Now, we're going to look at the inverse of exponentials, which is logs. Okay? So, y equals log of x. Another way to graph the inverse of something is to flip your x and your y's, right? But, we can just put this in a calculator because we want to stay consistent. We're going to y equals, let's put in log of x and close your parentheses. That's all you have. You have just the x. So log of x. Let's graph it and take a look at this. So if you look, you might look at this and go, wait a minute, that looks like a square root function. Because a square root graph looks kind of like an eyebrow. And I think that one looks like an eyebrow, right? The thing is, with logs, for some odd reason, your calculator's not very smart. This graph extends down. Even though your calculator doesn't show it, you need to show it, okay? It extends down along the asymptote. So let's go to second graph. Oh my goodness, you see all these errors here? That tells me that my graph doesn't exist there. So there must be something up and down, some kind of vertical line that blocks it, right? Okay. So it looks like it starts at 1, 0. Is there another pretty point that I can use?
There's 10, 1.
10, 1. 1, 0, 10, 1. Let's use those. Whoops. There we go. 1, 0, 10, 1. We'll use those two. I mean, you can use some of the decimals, but... So 1, 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. And it looked like there was an asymptote right at the 0, didn't it? Yeah, because that's where that graph kind of curves a bit. So when I go graph this, there we go. All right. You need to extend it down, even though your calculator doesn't do it. You know it extends down, okay? Now, exponentials, we put a star next to the domain because it was always all real numbers. But look at this domain. If you go from the left to the right of this graph, and when you're down here at negative infinity, does your graph exist? Is your graph here?
No.
No. Where does your graph start?
0.
0. And then it goes up to what? To infinity, or to the right to infinity, right? So your domain is from 0, which is your asymptote, to infinity. Now, what about the range? Don't you have an arrow going straight down? Negative infinity to what? It stops at 1? But you have an arrow. So that means that eventually this is going to go straight up to what? Infinity. So, wait a minute. Then the range is negative infinity to infinity? Isn't that the opposite of what it was for the exponentials? Yeah. Put a star next to the range. For logs, your range is always all real numbers. Now look at your asymptote. Exponentials had a horizontal asymptote, but logs have a vertical asymptote. And then put vertical. So B is what? Bucks or hoy? Bucks. So the equation of your asymptote is going to be x equals, right? This is x equals 0. Okay? Now let's talk about the increasing and decreasing intervals. This is going to be the same as your domain. Because that's just always the case with those, okay? If you have an increasing or decreasing, it's going to be the same as your domain. So let's look at this one. From the left, what is this graph doing? Good. Good. It's going up. It's increasing. So it's increasing, same as the domain. What is it? 0 to infinity. So it's decreasing nowhere. None. Now, guys, exponential. Did we have a y-intercept? Yes. So what do you think about the log for this one? Do you think this one's going to have a y-intercept? No. If it's the opposite, right? And look at your asymptote. Where is that asymptote? On the y-axis, yeah. Your asymptote is actually on the y-axis, so there is no way that it can have a y-intercept because it won't cross it, it won't touch it, right? So y-intercept is none. So now let's see, is there a 0? Is there an x-intercept? Yeah, at where? 1, 0, yeah. So let's go write that. Zeros at 1, 0. Negative infinity? Well, which arm is this one talking about? As x approaches infinity. Which arm is that? The right one. Alright, turn the music down. I can hear your music. I don't know who it is, but turn it down. So the right, that one is eventually going to go up. And it's going to go up to infinity. Okay? Because there's no horizontal asymptote, so that one's going to take a really long time, but it's going to go up to infinity. Okay? Any questions about this? That was the most painful part. Let's talk about transformation. Just like we did with exponentials, logs, they do the same thing. So let's start with my favorite, K. I like K. What does k do? Up if it's plus k, right? Good. So if it's minus k, good. Down k. Good. So then now let's look at x minus h. And that x minus h is always going to be in parentheses with the x right after log. Okay? So let's see. X minus h tells me that it moves how? Right. Right h. So x plus h moves how? Left h. Good. You gotta think opposites when it's with the x, right? So now let's look at A. So remember, A has 3 different jobs, right? You have a negative in there. Good. The negative tells me that it reflects. But what if your A number is greater than 1? Stretch, because it's bigger. Stretch. And if it's between 0 and 1, then it compresses. Yep. Okay. So I told you guys, if you see log, okay, if it's a log function, you have a vertical asymptote, right? Well, but Alex, how do we remember which one has a vertical and which one has a horizontal asymptote? Right? You're going to have to come up with something to help you. So here's the thing, guys. Sometimes you guys need to come up with some kind of a mnemonic device or something to help you remember things that you just kind of have to memorize, right? So when I always look back and I review these asymptotes, I always try to think of this, okay? See if this helps you. If you see the letters L, B, what do you think of?
This one.
What do you think of? I mean, there's no right or wrong answer. What do you think when you see LB? Huh? You think vertical? Level? Vertical line? Sure. If you like lift it. Alright. Well, you know what? Just to help you remember LV, I always think Louis Vuitton. Right? I mean, it's silly, but hey, Louis Vuitton. Some of my students in the past have said, oh, it looks like love.
I was gonna say that, but I stayed quiet.
Why? Why not? Okay, you can think love. Sure. You think love, I think Louis Vuitton, whatever, right? But here's the point, okay? Here's the point. Why LV? Because log functions have a vertical asymptote, okay? Log functions have a vertical asymptote. That's why I think LV. And you can think, you can think E for horizontal asymptotes for exponentials. Okay? Alright? Whichever one helps you. Okay? But it is up to you to remember which asymptote goes with which function. Okay? I was thinking LB. Then I know that logs have a vertical, and exponentials get the other one. They get the horizontal, right? Okay, so here's the thing with vertical asymptotes. Of course, it's x equals because that's a box, right? And exponentials, we always took the k, right, as our horizontal asymptote. Vertical asymptotes for your logs, it comes from opposite h. Whatever number is inside the parentheses with the x, give me the opposite, and that's your vertical asymptote. All right? Now we want to put a little star next to the range, because why? Okay, well for the logs, because it's always what? Yeah, always all real numbers. Always negative infinity to infinity. That's why I put a star there. Always. Now, your domain for logs is really easy. You ready for this? You ready?
Yeah.
Your vertical asymptote to infinity. It's never going to go to negative infinity because you can't take the log of a negative number. So let's look at A, B, and C here. I want you to tell me the transformations from y equals log of x. So we'll do the first one together. Flips, good. Or it reflects. What else? Good. Left, 3. Good. I want you guys to take a few, like a minute or two, maybe a minute. Try B and C, please. All right. Please be careful. For B, that is up 1, because that plus 1 is not in parentheses with the x. Okay, Mitchell?
Yeah.
Good job, though, on the compress. David Bat? No cussing in class. C. This is a stretch. 3 over 2 is greater than 1. Yeah? So just because you look at it and go, wait a minute, it's a fraction. No, because it's a greater than 1 fraction. So it does stretch. Okay. So let's look at example 1. We have log of x plus 1. All right, so let's do this one together.
Reflects left 1.
Whoa, reflects. Whoa. Just up 1.
Even a minus.
There's no minus
I
in
didn't
that.
see that.
So now, remember, logs, your range is always all real numbers. Let's see, asymptote. L, log is L, LB. So I know this is a vertical asymptote. Box, which is x equals. No, not always 0. X equals. And then we're going to look at here, this x. Is x inside parentheses with a number? No. So then that's like saying 0. Right? So this is x equals 0 here. Okay? And then guys, what did I say about the domain?
Vertical asymptote to infinity.
Good. Your vertical asymptote, which is 0 to infinity. So look at that. Even before I graph and put it into my calculator, I can fill in all of this information. So let's go to our calculators. Let's put this in. Let's go get some points here. So let's put in log of x. Make sure you close your parentheses after the x. Close because it goes up 1, right? And then plus 1 goes on the outside, like this. Okay, David, are you putting this into the calculator?
Yeah.
No. So it should look like this, yeah? And then you have second graph. So I would always choose the point right after error. I mean, especially if it's a nice number like that. So I have 1, 1 and 10, 2. Those are the two numbers that I'm going to choose. 1, 1, 10, 2. So I have a vertical asymptote at x equals 0. I'm going to draw my asymptote with a dotted line. And then I have 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2. Off a little bit, but that's okay. Can eyeball that. There we go. Sorry. All right. All right. So that's it. That's all you need to do with that. Let's try the next one. You ready? Number 2. What are my transformations here?
Left 1.
Good. Left 1.
Down 2.
Perfect. Guys, which one is the always? Domain or the range? Range. Always. All real numbers. Now, let's go and find the asymptote. Log LB. Vertical. What is 1?
Negative 2. Low.
X equals negative 1. Remember, you gotta go and get the number that's inside the parentheses with the x, and then give me the opposite. So right now it says x plus 1. Give me the opposite, so it's negative 1. And then, what is my domain?
-1.
Good. Negative 1 to infinity. Oh my goodness, so good. I'm going to go to x equals negative 1 and draw my vertical asymptote right there. And then, let's go and put this into the calculator and go get some points.
What's for mine?
Mm-hmm. Did you put it in like this? Did I do everything in right?
Yes.
Yeah.
Enter.
Alright, so make sure you put the x plus 1 in parentheses. Put the minus 2 outside of the parentheses.
Stop.
Huh? Remember, I told you it looks like it stops, but you gotta keep it going along the asymptote.
That clearly stops.
I know, it clearly stops right here too, but I told you your calculator is not very smart. You've gotta make it run down that asymptote, alright? I know. Calculator's crazy. 0, negative 2, and 9, negative 1. Those are the 2 points I want to use.
0, negative 2 on which one?
9, negative 1. Right? So 0, negative 2 right here, and then I have 9, negative 1 right there. Color, make it easier. There we go. And then I know your calculator looks like it stops right there, but like I said, it has to run along your asymptote, okay? I know, I'm sorry. I don't know why your calculator stops. Good. So, now what I want you to do is, actually let's go to number 4. On the next page, I don't want to start with that one at the top. I want to do number 4 just so we get a little bit more practice in with the regular law, common law function. Okay? Now look at this one. What are the transformations here, guys?
Stretch, left 4.
Stretch, left 4 and down 3. Good. Perfect. Now, what is my vertical asymptote?
-4.
Ah, negative 4, negative 2.
Wait, what did you say about the opposite? Isn't that for the asymptote?
Negative 4.
Yeah, negative 4. Good. Well, what is negative 4? I'll show you.
X equals negative 4.
X equals negative 4. Good. The opposite of the number that's inside the parentheses with the X. Yeah, I skipped 3. I'm sorry. I will go back to number 3. I want to do number 4 first. Now, which one's the always? Domain or range? Good. So range is negative infinity to infinity. Wait a second. If you know the asymptote, do you know your domain? Yeah. What is it? Oh my goodness. Breakthrough. So smart. Now, everything else, let's graph it, and then we can see. So x equals negative 4, I'm going to go and graph my asymptote. 1, 2, 3, 3, 4. There's my vertical asymptote right there. Now this guy, please make sure that you put it into your calculator exactly the same way you see it. I feel like you guys are doing a really good job of putting this into the calculator, right?
Yeah.
Let's take a look at it. Good, there's that stretch. Now, we're going to go to second graph. Let's get some nice points. I have 6, -1. Do I have another nice point? Oh, there we go. -3, -3, and 6, -1. Yeah? And you know what? Since they are asking for the y-intercept, I'm going to go and see what my y-intercept looks like. When my x equals 0, what's my y number? -1.796.
Yeah.
I'm going to say -1.80. Right? Okay, so I'm going to graph this. -3, -3. There we go. Pretty good, right? So we found our y-intercept, 0, -1.80. Now, increasing and decreasing interval, guys. Start from the left. Then this is going up. This is increasing. Good. So it's increasing, same as your domain. So from -4 to infinity. And there's no point in this graph where it is decreasing. That's you. And then as x approaches infinity, well, that's talking about the right arm, isn't it?
Yeah.
What is your right arm doing? It's going up to infinity. It's because this whole thing is increasing. So if it keeps increasing, we're going up to infinity. If this was decreasing, it would be negative. All right? So that is when you see common log, just log, right? Now let's look at number 3. Remember how when we talked about E in exponential, E is Euler's number, right? Told you guys it looks like Euler, but it's Euler. So E is an irrational number, right? Approximately what, 2.718? If you take a log with a base of E, right? Because if you have just regular log spelled out with no small number base, the base is 10, okay? But if you take a log and you put an E as your base, it turns into something called natural log. So it turns into ln, all right? So if you guys see ln or if you see log, they're both the same thing, okay? They're both logs, except one of them is a natural log, one of them is a common log. Yes? Okay, so it still follows the same rules. The only thing that's different is you're just gonna push a different button on your calculator, okay? So let's try this. Y equals -ln of x plus 2 plus 3. What are the transformations here? Reflex, left 2, okay, good. What is the vertical asymptote? What's -2?
2.
No, it is -2, but what is?
Vertical asymptote.
I know, but that's an equation, isn't it? I know. I'm so silly. I can just tell you it's x equals. But hopefully you remember it. Alright. Okay, so which one is always? Domain or range for logs? Range. Range is negative infinity to infinity. But you can fill out the domain for me since you know the asymptote. Good. Negative 2 to infinity. Alright, so I'm going to go and draw my asymptote at x equals negative 2. Vertical, so this is an up-down graph. And now let's go and put it into the calculator. So remember, put negative first, that negative sign, not subtract, right? ln is right here next to the 4. X plus 2 inside the parentheses, and then what was it, plus 3? Okay. Now I'm going to graph it so I can see what it looks like. Wow. Why does it look like this? Not because of the ln. What's in front of that ln? It flips. That's why it looks like this. It should, right? So let's go to second graph. And look, you see those errors? I don't want that. Negative 1, 3. Is there another good point? No? Okay. You know why? E is your base. That's why. You're only going to have one nice point. Negative 1, 3, and let's do 5, 1.05. Oh, and actually, what is the y-intercept when it equals 0? Okay, but since it's 2.306, can we say 2.31? Okay. 2.31. And I always like to get the y-intercept because they're asking you, right? 0, 2.31. See, negative 1, 1, 2, 3. 0, 2.31, right there. 1, 2, 3, 4, 5, 1.05. Yeah? So this one kind of dips down like that, but remember, it needs to follow the asymptote. So you need to make sure you draw that other half of it going up. Yes? Now tell me, what is this graph doing from the left? Good. This is decreasing. It's going down. So it's decreasing the same as your domain. Negative 2 to infinity. Increasing none. And so this one's a little bit different. Guys, what is your right end behavior doing now? It's decreasing, so it's going negative infinity. That right arm is eventually going to go down to negative infinity. Okay? Does this make sense? Yeah, feels pretty good? Good. I want you guys to try number 5. Number 5 is a lot easier than both of these. Please fill out everything. I know you can, and then I'll put up my answers and we'll compare, okay? Alright, so with this one, you guys have had some time. Let's check. When I graph it, I get these points. Transformation should be down 5, because this is your minus k. Your vertical asymptote is x equals 0. So your domain is from 0 to infinity. Your range, of course, is always negative infinity to infinity. Well, if my x equals 0 is my asymptote, well then do I have a y-intercept? No. Alright, so that's none. I have 1, negative 5, 2, 3, 4, 5, 6, 7, negative 3. There we go. Now this whole entire graph from the left to the right is increasing, not decreasing. And since the whole thing is increasing, my right end behavior is going up eventually to infinity. Yeah? Great.